Welcome to this presentation on how digital twins are transforming the construction industry, mainly in addressing delays. Today, we will explore the problem of construction delays, how digital twin offers solutions, and analyze the impact of this technology. Digital twins are the virtual replicas of physical structure that update in real time. You can see the background image showing a virtual representation as well as what the actual physical structure would look like. They bring data-driven insights of project management from planning to maintenance. The construction industry faces serious issues. Projects often run 20% longer than expected and can go up to 80% over budget. Traditional construction lacks real-time visibility, which makes it hard for managers to spot problems early. This results in delays, wasted resources, and increased costs. Current methods like manual site checks are labor-intensive and prone to error. They often don't provide real-time data, meaning managers can't always see issues as they happen. Studies show that these outdated methods contribute to costly mistakes and delays, underscoring the need for more accurate and immediate tracking. Delays are not just an occasional issue, but a persistent problem. Over 70% of projects experience delays due to various factors, whether it's weather conditions, labor shortages, or material delays. These challenges can push timelines and budgets beyond what was initially planned. A survey done in the UK talked about what percent of all projects are subject to delay. The data collected showed in 2016, most respondents estimated that 30% of projects experience delays. However, by 2022, this figure has dramatically changed, with 28% of respondents reporting that more than 50% of projects were delayed, up from 15% in 2016. This increase highlights a significant rise in construction delays, leading to higher costs and longer timelines.
So let's talk about digital twins. Digital twins are a virtual representation of a physical entity of the built environment. They provide an innovative solution to the problem of delays. By creating a virtual replica of a construction project, real-time data can be collected and analyzed. This allows project managers to monitor the project's progress, identify potential issues as they arise, and make adjustments in real time to keep things on track. As shown in the image, data from the physical world is collected through various sources such as sensors, cameras, GPS trackers, and RFID tags. This data is then processed using AI algorithms to create a virtual representation of the physical assets, such as buildings, windmills, and engines associated with the project. Digital twins have gained significant traction in the construction industry, but widespread adoption is still underway. Despite their potential to revolutionize construction by enhancing efficiency, reducing costs, and improving project outcomes, digital twins are still not universally adopted. While the technology reached its peak of inflated expectations around 2018, it's now progressing towards maturity, which many companies integrating it into their workflows. However, barriers like high implementation costs, a need for specialized skills, and the lack of industry-wide standards still slow down adoption. As the technology matures and more companies recognize its value, digital twins are poised to become more prevalent, offering long-term benefits in design, construction, and maintenance.
The origin of digital twins trace back to the 1960s, when NASA developed early concepts to monitor and mirror space systems on Earth. A famous example is the Apollo 13 mission, where engineers used a physical twin of the spacecraft on Earth to troubleshoot and test solutions, ultimately enabling the crew's safe return. This use of twin was groundbreaking in showing how virtual and physical modules could work together in real time. The term digital twin itself was formally introduced in 2003 by Dr. Michael Greaves at the University of Michigan, where he defined digital twins as a virtual replica of a physical entity.
Examples of how this technology has been implemented in the construction industry include the Crossrail, which is part of the HS2 project in the United Kingdom. Digital twins were used to simulate and optimize workflows, resource usage, and ensure quicker delivery of projects. A second and more successful example is the Huawei Airport in China. This project involved 29 different disciplines, each consisting of over 50 parties with over 600 on-site personnel. They used digital twins to resolve over 6,000 issues before they occurred on-site. This improved productivity by 25% and led to a record 2-year completion time. The benefits of digital twins are clear. First, they provide accurate, real-time data, reducing the risk of errors. Second, they foster collaboration, allowing teams to share updates instantly. And finally, digital twins enable data-driven decision-making, helping project managers optimize workflows and improve outcomes. Managers can spot potential issues early and make informed decisions and ensure projects stay on schedule. This technology allows for a more proactive approach to construction management.
So let's talk a bit about the SWOT analysis, which is the strengths, weaknesses, opportunities, and threats. When it comes to strengths, digital twins offer several advantages. They provide accurate real-time monitoring, significantly reducing the risk of errors. The real-time data allows for enhanced collaboration between project stakeholders and supports data-driven decision-making, ultimately leading to more efficient project management. However, there are several challenges to this adoption, which could be considered as its weakness. The high initial costs and the complexity of setup can deter some organizations from fully implementing digital twins. The need for specialized skills and infrastructure can make it difficult to get started. Opportunities. So the potential for digital twins is immense. As the technology matures, we are seeing increased adaptation across the industry. There's also a growing opportunity for integration with other technologies like AI and IoT, enhancing their functionality. Furthermore, digital twins can enable new business models, opening new avenues for innovation in construction and building management. Threats. Despite these opportunities, there are significant threats. Data privacy and security concerns are a major consideration as digital twins rely on continuous data collection. The technology also requires a robust digital infrastructure, which can be a challenge for smaller firms. Finally, digital twins face competition from traditional methods, as some may prefer to stick to tried and tested techniques rather than adopting new digital approaches.
Let's now look at the cost analysis for implementing digital twins in construction projects. The variables include initial setup costs, maintenance and operation costs, training and interpretation, long-term savings. The first major cost is setting up the digital twin system, which includes IoT sensors, data infrastructure, and the customization of software. These costs are typically higher for large-scale projects due to complexity and scale of the data required. For the maintenance costs, once the system is in place, there are ongoing costs for monitoring, updating, and maintaining the digital twin to ensure it remains accurate and reliable. These expenses are critical for maintaining real-time construction tracking throughout the project's lifecycle. Training and integration. Another important cost is investing in staff training and adapting workflows to incorporate digital twin technology. These costs can vary depending on the size of the project and existing infrastructure in place. Despite the upfront costs, digital twins ultimately offer long-term savings. They help reduce waste, improve operational efficiency, and enable predictive maintenance, ensuring a significant return on investment over time.
In conclusion, let's wrap up by saying digital twins offer a transformative approach to construction. They help reduce delays, improve resource use, and align with certain sustainability goals. As digital twin technology advances, it is set to become an essential part of construction, driving projects toward greater efficiency and reliability. Thank you, and let me know if you have any questions to ask.